What's up, everybody? My name is By Getroman, and this is Built by Getroman. Welcome. In this video, we'll be picking up where we left off with going over a coding challenge from Algo Expert called 2 Number Sum. So, my job is to try to solve this coding challenge in this episode. So, if you watched the other episode, great, and if you haven't, I'll link the card above and I'll link it in the description below. So if you're interested and want to take this ride with me as far as trying to solve coding challenges and get into the realm of public learning and fumbling and getting back up and trying to solve issues and problems when it comes to software engineering, then you're in the right place. So stick around and keep it locked. Okay, everybody, we're back. So, as I mentioned before, we left off at 2 number sum, so I'm looking to dive right into this. Similar to the last live coding challenge we had video, the structure is gonna be the same. We're gonna follow the Pomodoro technique, and it's gonna be timed basically. We're gonna just follow the focus times, which are the 25-minute sessions, and then take actual breaks, which are 5 minutes long. So we are going to do 4 25-minute time slots of just coding, problem solving, and just trying to solve this first coding challenge. And then we're taking 5-minute breaks, increments of 5-minute breaks in between those 25-minute coding sessions. We're doing 4 of those. All right, so let's get started. All right, where we left off, basically at 2 number sum. I'm gonna set this timer up here for us. Okay. Bear with me here. I'm just trying to get this timer back over here. Awesome. There you go. On the fly. Alright, so let's start this timer at 25 minutes. And we're off to the races. Let's see, is it working? Yes. Alright. Alright guys, so 2 number sum. We left off the last time basically stuck at a certain point where we were we created 2 for loops basically, and let me just show you. Right, we created 2 for loops. I created 2 for loops, and I followed some of the notes that I created back here in the scratch pad. And again, if you haven't seen that, just go back to the other video and you understand what I'm talking about as to like how we got to this point. So we're at step 6, I believe. No, we're at step 5, right? And the intent was to loop through the same data set that we had created, that's coming in, which is the input, where we wanted to take that array and basically do a nested for loop so that we can have two different pointers, and the first pointer would always stay put in within the first for loop, and the second for loop's job is to iterate through the array and just kind of go through each other element. But while it's doing that, we wanted to basically track it and then also compare. So take that first element and compare it to the next. Add those two numbers up, and if that number is equal to the target, then we have a match, and then we have to return that pair, those 2 pointers. Okay, so that's kind of where I left off, and we're gonna pick it back up. But before I do that, I'm going to have a glass of water. Salud. Need that sometimes. All right, so I wonder, the last question that was in my mind, I was wondering if the debugger keyword actually worked here, and I'm not too sure actually. So let's see if this works, right? So we want to basically, actually let's run it, right? So we in here we have a function, we have an array and a target sum coming in. We instantiated some some variables that hold some sort of values, right? We wanted to see if we wanted to know, I think at this point, looking at this console.log, to see if we have a pair match between the two for loops, as those numbers are going through each of the elements, and as they're comparing to each other, doing the addition, and they're doing some addition, and then they're comparing. The result will be compared to the we called it the target sum. So I'm gonna run that real quick, and I know we are failing some test cases because I recall we were missing something. But let's see here. We have a paired match between 4 and 6, which adds up to that sum, whatever sum that is. Okay. And test case 3 is printing out an empty array. Test case 3 is printing out an empty array, which shouldn't be, because test case, let's compare these test cases. Let's go about it that way, okay? I just realized that there's a hide button here. This is my first time using this, second time actually. I wanted to do it and be like authentic with it. Basically, I don't want to like look at it beforehand and try to figure it out. I wanted to do it on the spot. Again, to really show how like real programming works, you know. Don't know the answers. I don't know everything about this, so I'm learning on the fly, alright? Public learning, guys. Alright, so test case 1 should be printing target sum here, right, of 10. We're getting an empty array. Here, test case 2, we have an array of 4, an array that holds 2 integers, 4 and 6. Target sum is 10. Oh, well, yeah. Oh, that makes sense. Okay, let's go to test case 5. You have this array of integers and a target sum is 17. So test case 5, we're saying 8 and 9 is the match, okay? And 8 and 9 equals 17, and that those paired numbers should be returned, but we're not getting that. So let's just go to test case 5. Actually, yeah, we're getting that. Oh, it's passing. Okay, interesting. That works. All right, let's go through each one. We know that the other ones are is empty array, so that's why I skipped those. Oh well, that's the only one I got besides 2 which is obvious. Only two numbers in the array that's going to equal to. That's kind of a given. So I failed everything except test case 5, which is extremely interesting. So there's some error in my logic, obviously. Obviously, there's some error in my logic. Okay. So let's look at that. All right. Let's close this down here. So I stored the pointer in the second for loop. Oh, here's the first for loop. Create a first pointer variable. I stored it in the variable for comparison purposes, which is here, the first pointer. I created a second for loop with the second pointer, and then I did the addition here. So that's working, right? Those things are looping through each other, and they're making some addition, and that number is being identified, but it's definitely somewhere here in my my condition. And I wonder if I remove this and remove this break, see what happens here if I were to run that code. What kind of response would I get? I freaking passed. Ah! Okay. I wasn't expecting that. I was not expecting that. Here's why. If you remember from my last video, I want to rewind. In my last video, I added the breaks because somewhere in my thought process, I did not want the loop to continue to run if we found the pair very early in the array, in the data set. What I didn't want was, like, I found a pair with the first two elements, element 1 and 2, index 0 and 1, right? I didn't want the loop to continue going. So I thought the breaks would stop that, but then again, it wouldn't. Now that I'm thinking about it, because that's essentially what the condition is for. If these two numbers are met, we print this stuff out. But wait, does the if statement actually break the loop? Is that a thing? Is that a mechanism for the loop to break in itself? So do I have two kind of breaks? See, I need to look that up real quick, just to be, I want to make sure. I may be confusing myself here, but let's just say, does a for loop, I'm sorry, does a if statement of condition break a for loop? JavaScript. How we doing time here? You got 15 minutes. Okay. Awesome. All right. JavaScript break statement, break and continue. How to stop a for loop. I'm just curious. I'm curious to see. Now that we solved this, I wasn't expecting to solve it that quick. I thought it was some bigger issue going on. So here, this person's saying, I'm using this JavaScript to iterate through an array and find a matching array element. So he has an empty array he instantiated. Some additional, I don't know what this is, to be honest. Oh, he's storing it all in the same variable. Okay. The array contains these sizes, 34, 36, and 38. To stop a for loop early in JavaScript, you use a break. Okay, that's okay. So you need a break. Okay, so the if statement is just a condition, right? You know, I've written conditions a million times, and honestly, I just forget that if there's some hidden feature that I might have overlooked. But conditions don't break for loops. Okay, they're just meant to monitor, have the eyes to say, hey, is this thing equal to this thing? Does this thing it doesn't equal to this thing? And that's all it does. It doesn't stop the actual for loop, right? So confirmed, the break and continue breaks the for loop, which I initially done before. And in the previous video, I had a break statement in my code because the intention was to stop the for loop from continuing to run. So I was kind of thinking a little ahead of myself when it came to optimization. Um, so that worked. So I'm just gonna remove the break statements again. The other thing I actually wanted to do was to test to see if this algo expert did it have accessibility to the browser console with respect to using the debugger keyword. All right. So I kind of want to see if that works. I'm gonna open up the console here, and automatically when I run it, it should pick it up. I know other websites I use, online IDEs and text editors, online IDEs that are web-based, they work. So I don't know. Let's see if this works. So if I run it, I pass all the test cases, great, but I don't see any output that has anything to do with the debugger keyword. Which I didn't add. Oh, I did add. That should have picked it up. That sucks. That part sucks. Just because like I'm a big fan of the debugger keyword. I use it a lot to track every like line and see what's happening, what's going in, what's going out when it comes to using for loops and things like that. So it's not working here, which is a bummer. So I may, if there's a case where I need to use it, I may have to remove the code out of here and put it some other website, web-based IDE, maybe like a REPL or what's the other one? What, I forget. There's like a couple other that I use. So I'm gonna have to do that and just move some test cases over and see what happens, so I can get some better understanding of my logic. But yes, so cool. So we found out two things. The debugger keyword doesn't work for us. So when it comes to these other videos I'm gonna do on Algo Expert, we know that that's not the case, and it's not gonna work unless I'm missing something. And just to confirm, let's look it up. Does the debugger keyword work in Algo Expert? One word. Drink my water. All right, guys. Also, I have a new playlist. It's called Bass Nation. It's a royalty-free music. So I had to like do some research on that. So anyone who wanting to do YouTube videos, do your research, man. You don't know, you don't want to get copy struck, or if you're monetizing your videos, you don't want the money to go to the artist if that wasn't the intentions. But if it was, then great, you're supporting that artist. But keep that in mind. Something I learned when it comes to YouTube, right? Like specifically this. All right, so we're getting a lot of like queries on how good is Algo Expert. Is it free? How do we use the debugger script? I don't know. Let me just check the website to see if they have like a Q&A, since we have a little time. We've got 9 minutes here before our first break. Is there like a Q&A session at the bottom here? Don't you love ads? FAQs, even better. Product bug report, feature requests. Alright, so I guess I'm just gonna put in the request for a feature if I don't see this in the next like 50 seconds. Common issues, workspace issues, syntax issues. Oh, this guy started about all the things. Why don't you name Python functions and variables with the snake case convention? All right, this is a different request. All right, I'm gonna move on from this. I will put in the request for Algo Expert to include the debugger keyword, which, let me just make sure it's not buried in the settings here. Yeah, whiteboard mode, data structure visualizer. Ooh, what's this? What is this? Binary tree is represented by a list of nodes and root node. Is this what I wrote out, or is this like some supplementary work, visuals for what's gonna come next in this coding challenge? Because we still have other steps to look at, right? Well, link this 0, 1, 2. All right, we'll definitely look at that later. It's great that that's available. There's some syntax highlighting here. All right, I don't see it. It's not ringing out to me like right off the top, but I put in the request. Maybe something that they can consider down the road. Cool. So we're passing all the tests. Great. So let me clean up the code here. Remove some of these logs. Okay. I didn't need. Well, I'll get to that later. I'll do some optimization, cleaning up later of the variables and stuff. But I just want to move these logs. Oops, what did I do here? All right. Awesome. Muy bueno. We did it. Awesome. All right. So, two number sum, guys. We were able to get this far. So, just to kind of go back into this REACTO framework, I'm gonna actually pull up a different screen here. So here's a better like visual that I didn't supply the last time. But here's something that I grabbed from another resource, as I mentioned in the first video. But I'm following this. This actually is pretty helpful, right? So we got the repeat. REACTO has nothing to do with React, the library framework, JavaScript framework. It really just has. That's the way the acronym played out. So the R is for repeat. So what I did was, when you first encounter a coding challenge, you repeat the question over and over, just to get some clarity and get some of the language, get an understanding of the language, and then you do that a couple times just to make sure you get an understanding of the context of what the question's asking you, which is like the hardest part initially. Is like, how do I understand this question? All right. So the second part to this is the E, the examples, which in my world, the way I think is, all right, examples for me would be like this like chicken scratch you see in front of you. Honestly, that's what it is. And it's just thoughts thrown on the whiteboard, on the chalkboard, and we're seeing what sticks and we're seeing what doesn't stick. I don't, it could be right, it could be wrong. Just throw it, whatever we know up there, and hopefully it makes sense, right? So that's what's happening here. And so this is the example part, right? Just kind of mapping things out, mind mapping, right? The third thing, we did the approach. The approach is which way are we going to solve this in terms of like, is this going to be a recursive approach? Is this going to be an iterative approach? Is this going to be more of a, and I forget the term they use, but it's like a mathematical approach. Are we going to rely on just straight math to solve this, or something along those lines? Then we got to the C, which is the code, which was this. Is two parts to this. Is the pseudocode part, which we did with the scratch pad, and I go back here, right? The scratch pad is basically taking that chicken scratch, the notepad, from the examples page that we wrote and drew out, and then formalizing a little bit into notes, right? Right or wrong. and I'm very sure a lot of you, if you're watching this, have identified many errors. Uh, too many variables I'm using, or the approach could be a little bit done. There's more refinement that can be done, and to make it more efficient, you can turn this to 2 lines or whatever, right? Uh, I went down the imperative way, step by step, instead of the declarative way, is to show me is to do it versus show me how to do it, right? So cool. So now we have solved this specific problem, and next what I would like to do is actually visit the next piece of this, which is the T. It looks like my notepad's not working right now, but the test, right? The testing part of it, which in my mind, we kind of did that already. With running the code, I think for me, running the code is the test, right? Running the code is the test, and we passed everything. Um, I need to understand what the T does, or if I'm missing anything from the testing part of it that's out of the scope of what Algo Expert already provides for me. Because there's a lot of unit tests here um, that they provide for us, and it's already kind of done. So I'm gonna say check mark on that one. All right. So um, moving on to the next is the optimization part. So this is the part where I want to challenge myself after our break to understand the code base a little bit deeper from a efficiency standpoint, from a what's a better word? Nah, there's no better word. From an efficiency standpoint. So when I say efficiency is really testing and understanding the big O notation of this coding challenge. Like, where does it lay as far as like how efficient is my algorithm? So I'm gonna challenge myself to identify that next after the break, and see how far off I am, or how on point I am when it comes to time and space complexities. Okay, so yeah, let's enjoy the music. All right, guys. So I'm gonna call it now. I'm gonna take the break a little bit earlier than so. We'll go about 40 seconds earlier than expected, which is great. We're on time, and cool. This is our first Pomodoro break, our 5-minute break, and enjoy it. See you soon. Hey guys, we're back. Starting the timer here. Awesome. Okay, here we go. Timer's back on. All right, so moving on to the next part of this, which is the last part, is the optimization piece of it. So again, we're talking about big O notation. And my job, well, let's just start with this. I am, I'll give you a quick brief history about my like computer science knowledge. It isn't much as far as a formal education is concerned. So I'm not a traditional computer science student. I'm a self-taught developer, as you know by this point, and really pretty much have been tippy-toeing around tackling questions about Big O and optimization, which is something that I haven't had a need to do, honestly. So it's not really more about tippy-toeing around. I just haven't had the need to like answer a coding challenge that needed some answers regarding Big O notation. So I want to get better at it. I want to understand Big O as far as time and space complexities at a deeper level. So here's my first attempt in doing it. All right. So with regards to optimization and Big O, I'm wondering the question I want to answer for myself is, what is the time complexity of this coding challenge? One more thing I wanted to add. I have been studying Big O notation for about 2 weeks now. I set out a 4-week plan to really dive into Big O and be like competent in it to a point where I can at least articulate myself in a way where it makes sense to myself first, and then the next person I'm speaking to, which more than often will be in the setting of a coding interview, which by the way I'm getting ready for. I have an interview in 2 weeks, so I'll talk about more about that later on. All right. So what is the time complexity of this code here? So So we have the first thing I'm going to look at is, what type of data structure am I working with when it comes to this? I'm working with an array, right? So how am I traversing through that array? That's the first question I'm asking myself. And from what I've read and understood so far from other YouTube videos and cracking the coding interview and other videos that I've read and seen in books that I've read so far, that my initial thought is that this is going to be, because of the for loops, or at least the first for loop, that I need to traverse through the whole array from beginning to end. Okay, so we have an array. Right, so let me draw this out to make sure that I'm making sense to myself. So I know that the first data structure that I'm working with is some sort of array, right? It's one array, right? Let's see, it's one array, and we have a target sum, okay? We have one array. We have one array with a set of numbers, 6 and 10, and I know we set up the first pointer here, right? We set up a pointer here, it's called a P1, and I have to eventually go through the whole array. Depends how, it depends where the match is at. All right, it depends where the match. Depends where the match is. Okay, so now I'm thinking about something else. I need to identify uh, uh, best case scenarios, average average case scenarios, and worst case. Sorry for this chicken scratch here. I'll get better at writing. Best case, average case, worst case scenarios. Right. This is the question I need to answer from as far as time-based complexities. Which one is it? So the first pointer at its worst case would need to traverse to every index if the pair or one of the integers in the pair sits in the last index of the array. Right? So you're looking at a linear traversal, right? So that's going through each of those elements. So my first initial thought is that this is going to be a O of n at its worst, or average, I guess. I'm not sure what bucket we're gonna put that in, but a big O of n, right? Make that look better, because big O of n says big O of n describes a complexity that grows with the size of the input, the data input. So as the data input grows exponentially, so does the data, right? It grows. So as it grows, so does the loop. The loop gets worse over time. That's what I meant to say. As it grows exponentially, the looping of that data set, in this case is an array, and I have one for loop. If that data set were to grow, then as far as like, and let me see if I can draw this out, because I need to get better at this myself. As far as this graph is concerned, if I'm not mistaken, it's something like this, I believe, which is big O of n. So this is linear. It grows slowly as the data set X grows. Okay, so I think at its worst case, it will do that. I think also at its average case, it'll do the same thing. And I don't know if I need to answer this question when it comes to coding interviews. I'm not sure if this is what they want, all three. You know, is it best or worse? But I'm just following some of the strategies I'm finding online and just through my learnings and my time as an instructor, which again is I taught code newbies the basics, right? So here I am actually learning again myself, and which I'm always learning. By the way, this is something that I love and I strive on, is learning new things. But anyway, I could be wrong at this, so we're gonna verify this later on as far as like the graph is concerned. But I do know that because I'm looping through this data set, this array, that it's gonna traverse in a linear format. So in my mind, it's okay. O of n, big O of n, which is linear. All right, cool. So let's move on. Um, Now we have how am I traversing through that array? Not how, I guess how often. How often am I traversing through that array? Right? And what mechanisms am I using to traverse through that array? All right? So I'm thinking that these two here, these for loops signify something to me. And I remember reading about this and seeing a lot of examples of this and writing some myself, that we're doing double the work on the same array. So because we have two for loops, I believe that's going to be, and I need to look this up again, and maybe, well, let me draw it out before I get to that point. So now we have a second piece of work on the same data set. So we have pointer 1, which is the first for loop, and then I'm just gonna replicate this array down here. Actually, let me erase this. Right, I have just gonna make it a little smaller. A second for loop set up here, which is P2. Okay. Pointer 2. And that has to traverse down the array as well. So that's two loops working on the same data set. So, Jesus, what was that? That was, I think that's maybe polynomial time. I have to look that one up. So, because there are two loops happening at the same time, so it may be polynomial or exponential. No, I think it's polynomial. I have to go back to the notes. We'll actually look it up in a sec. But I know that whatever that term is, it describes an algorithm. It describes the data set being powered to the second, whatever power, right? So if there's three loops, it'll be O of n to the third power. So it describes a data structure that's powered to whatever number. So here it's O of n of 2. Okay, I think, and I need to go back and confirm that. So cool. Next, I want to actually go back and see what else am I missing from this code that I have not covered yet. So we have two loops. There's no other loops happening here. I'm not doing anything else with that array. All right. So best case. So best case, I'm thinking that because at its best case, the pair is in the first two slots of the array. So index 0 and index 1, right? At its best case, it's here and here, right? If we're lucky, it's sitting in the first set, the first two numbers. So the big O that describes that is constant time, right? So that's O of 1. So big O constant, basically constant time basically describes a an, an complexity that basically uh, selects. Oh, there's a constant selection of a node or an element in an array that's the same one. So if we're selecting the first element and the second element consistently, those two, then we're not traversing through the array. We're just literally we have a spot in memory that we always go to, and that's like the quickest thing to go to, right? So for example, I'll give you the best way I understood it is like say you have a deck of cards, right? You have a deck of cards, and in those deck of cards, I always tell you to choose the second to last card. Every time I give you the deck of cards, I always tell you to choose the second to last card, or I tell you to choose the first card for every deck of cards I give you. That's pretty easy because you know where to go. It's the first card. So that's how I recall constant time. So my guess is that this this coding challenge, these two for loops at its best case is big O of 1, just constant time. All right. So what's next here? All right. Let's give space complexity a time. Let's see if I can figure this one out, given at least an attempt to figure it out. All right. So space complexity. Let's see. What is the space complexity of this here? So, So we have, as far as space is concerned, um, we have one array we're working with for the most part. Um, and what I haven't done also is I didn't take out any of the stuff we didn't need, like that extra is paired variable on line 4, right? That's something that I did not remove. But for the most part, the only like real piece of storage that we're working with is this array, but I do not know how to translate that or communicate that to space complexity. Okay, and honestly, I'm gonna take a guess at this and just my educated guess, and then we'll look at some references to see if that's true or not, to confirm or deny my statement or my theory. All right, so we have an array, and I'm assuming that because it's an array and some of the capabilities we have in that array is being able to select a specific element at any given time, that this is going to be at its best case constant time, a constant space. Excuse me. Why? Well, because of what I just mentioned. Because of the ability to, in my mind, since you have the ability to select certain elements at any given time, that this becomes in my head the best case, which would be constant time. At its worst, I'm gonna go back to linear time. Okay, at its worst, linear time. All right, I like that song better. All right, let me get a swig real quick. All right, guys. So this is my thinking here. I'm not sure if it's right or wrong. Again, I'm still learning Big O, and what better way to try to learn it is to actually do the thing, right? Actually code and challenge yourself uh, live on YouTube and in front of people, and try to and try to like verbalize and articulate what you think is happening. So you know, let's spend some time now seeing if I'm right or wrong, and if my logic was off, totally off base. So don't judge me, guys. All right, cool. So how do they provide this here, and do they provide that information here? I thought they did, because that was kind of his thing here. So they do provide the solutions, which I'm on the honest system here. I do not look at the solutions, and if I do and I plan to, I'll make a strategic way of doing it and explain why. If I get super stuck and I exhaust all of my options of trying to find help. Okay, so I thought I saw something earlier about a data structure. Is it this? Does this explain to us what's happening here? This is just giving us the data structure for what exactly, or is it just explaining it? Linked list. It's just talking about the different type of linked lists that exists in a binary tree. Okay. All right, that's not it. Is there like a test for? No, I don't want that. For data structures here, quick test. Nope. Show. We don't want that. Scratchpad. Our solutions. Let's go to solutions here. Do they talk about? Nope. Video explanation. Go through code walkthrough. Go to conceptual overview. So I guess he talks about it in the video, which I have. I don't know if I want to watch that while I'm actually doing a video here, which maybe I can do. Maybe. I mean, it'd probably be beneficial for those who don't have this website, access to this website, because I did pay for this. I paid a yearly fee for this website, so maybe it'd be helpful if I just play it and we'll watch it together. You know what? Screw it. If I don't find anywhere else, and I'll save this for the break, but if I don't find anywhere else that actually has anywhere in this website that provides me with some explanation about the complexity, the time complexity, the space complexity of this coding challenge, that's like in words where we can see it in some sort of graph, then I'm just gonna play the video and see what explanation is provided for us. It is 28 minutes long, so I may just skim through it. Honestly, I'm not gonna probably go through all of it here, but if you want me to do that and just play the video at the end, then leave a comment below. Let me know if you want me to actually play the videos or not at the end, after the coding challenge is solved. Okay, I'm leaning toward yes, but I kind of want to hear from you guys. So I'm gonna skim through this after the break. Okay, so let me just make sure there's nothing else I'm missing here as far as the prompts. Oh, look at this. Oh, wait, what's this? So optimal space and time complexity. Wait, O(n) time, O(n) space, where n is the length of the input array. Is this the answer to the space, time and space? What do we have for time? O(n) let's go back to time. We said for time, best is, we said best case is constant time. Okay, at average we did say O of n squared because there was 2 loops. Here it's saying just O of n time. Okay, so we're kind of off there. So I do want to see the explanation. Now that we saw this, which I'm assuming is the answer, and then we have the space was saying that this is also both of them are linear, where n is the length of the input array. So for space, at its worst linear, at its best constant. So a little off there as far as the logic is concerned. So what we're gonna do after the break is actually skim through the video and get some perspective as to what the space and time complexity is and why. So don't go too far. We're gonna take another quick Pomodoro break, and I see you after the jump. All right, guys, we're back. Let's get into this second, actually third Pomodoro, our third round, which is a 25-minute round. So I'm thinking, I'm gonna skim through this video um, that explains the solution here. So let's actually do that together. And if you're looking and interested to actually watch the whole thing because you don't have access to this, I'm more than happy to do that for you guys, right? So, because again, I paid for this out of pocket, I'm okay with sharing this information out. Um, Hopefully, I don't get in trouble for doing that. But all right, so hopefully, I don't get in trouble for doing this like on YouTube. We'll find out. So let's play this.
Hey everybody, welcome to Algo Expert. In this video, we're going to be covering the question of the two-number sum. This question basically gives you an array of distinct integer values, meaning that no number in this array is repeated. And it also gives you a separate integer value that represents a target sum. And sum 10, we want to find if there's a pair of two numbers here that sum up to 10. All right.
I'm
So
gonna
we've
skip
got our
to the.
two-number sum function.
So I'm skipping to the code walkthrough because I want to see the part that talks about the time and space complexities. I hope this has the best resolution. Awesome. Okay, so let's walk through that part.
Find it takes in an array of distinct integers and an integer target sum. We're going to use just a dictionary here in Python or a Java. And then
Okay.
in the hash table. So I hope this video was helpful. I hope it.
Oh wait,
using.
here's
Let's.
two examples here. Okay, let's back up then.
All right. So we've got our two-number sum
So I'm actually gonna walk, just kind of stick around and see this last couple of minutes here.
function defined. It takes in an array of distinct integers and an integer value representing the target sum. And so we're first going to type out the solution using the two for loops, which is going to run in O of n squared time, where n represents the length of the array. For that solution, all we have to do is literally implement two for loops. So we'll say for I in range len of array -1. We want to go all the way to the before last value in the array. And then we can say current num, or rather first num.
Speed up a little bit.
Declare our first num variable is going to be equal to array of I. And then we can say for j in range I plus 1, len of array. Here we can, we're iterating through all the rest of the numbers in the array. We can say second num is going to be equal to array of j. And here it's important that j goes all the way to the end of the array, right? And then we say if first num plus second num equals target sum, then just return an array of first num and second num. And we're done, right? Then at the end, we can here return an empty array if we've never hit this return statement in the double for loop. So that is the first way of solving this problem, and that's going to run in O of n squared time and O of 1 space, because we're not using a hash table, we're not using any other kinds of arrays or anything. All we're doing is storing two extra variables, which we don't even need to do here, it's just for readability purposes. And then at the end, we're returning either an empty array or an array of two values.
Okay.
All right, now the way that we really covered in the conceptual overview, which uses the hash table, this is going to be a bit different. So two numbers.
So I didn't use a hash table, so I'm gonna stop there. Okay, so I did the iterative approach. I didn't use an object to store any numbers. I didn't track it. I didn't go about it in a way where I had an object stored that would store a key value pair. For example, I would have done it in a way, and now that I think about it, where if I had used an object or hash table, where I would have stored two key value pairs with the first integer and second integer, and use those two to say that if these two add up to the sum, then return that pair, so something along those lines. I haven't thought about it really, but the point is, since we used the two number sum, the top one, this is the one we wrote, that I wrote earlier. Uh, Now that I look at the time complexity here, which is different than what was provided for us in the environment that was given to us, which is actually down here in the test. All right, was it the sandbox or the test? Or the solutions? No, video explanation. Where I found it, I forgot where it was, but it's saying here now that the time complexity is big O of n squared, which is actually matches up. Let me make sure this is time, right? Big O n of squared. If you go to the time, we did say average. It is big O n of squared, and I want to know the exact term for that, which I felt like it was polynomial, but I could be wrong. But this is good though, so I was right, which is great. That means that what I'm reading is actually sticking to my head. It's actually sticking in this brain of mine, which is great. Um, so yeah, big O n squared time, because there's two loops doing the same work on the same data set. And then he said the space is constant time. I don't know. I don't know. I have to go back to see and understand why he said that, but I overheard him say something along the lines of just because we're using one array. And that array, well, actually, he didn't explain it um, to that extent, but I'm going to assume this for it's because of the thought process, because of the kind of the theory I had in mind of like the space complexity, the abilities of that array having the ability to target an element, any specific element at any given time, uh, makes it constant time. Oh, excuse me, space. All right, so let's just match that up here. Let's see. So from the time complexity standpoint, I was on point. As far as the best case, he didn't actually go over best, average, or worst. So I don't know if that's something. Again, I'm just gonna try to do it this way, just because I don't know in my interview they're gonna hit me up and say, hey, what's the best case, average, and worst? And if I haven't practiced that, at least I got some. I don't want to like a fool and stumble upon my words, which I do a lot. While I'm thinking, because I'm thinking kind of very fast, but my mouth and my words are not catching up to my thoughts in my head, so I need to slow down. It's something I want to practice on. So throw a little music on here. All right. So it looks like I'm kind of right here, I'm gonna say. So before I move on to the space complexity, I want to know what this was called again. So let's do a Google search. It's just to see if it is polynomial. Okay, so let's just do a Google search. What is big O of, let me do a space here, and where's that little character at? Just do that. Do we have that there? Oh. What was this here? Thought I saw it down here. Two N. Okay. So what we have here is big O. No, that's not what we want. We actually have. We wrote big O and squared. So I did that wrong.
Sum array target sum.
Big O of. So this is actually I did that wrong. The query was wrong. And squared. Big O. So that's this, right? N squared, is that the same thing? Big O of N squared is, you know what? I'm gonna go to an article that I know I have access to, which is my old boot camp that I went to. I still have access to their curriculum, which is cool. Hopefully, awesome. I do still have it logged in. Let's see, server side. God, this is so old. I haven't touched this in forever. Server side, learn essentials, prep. Where did they go? Learn React, server side, web development, learn to learn, intermediate, advanced topics. Okay, here we go. These guys did a good job of like outlining each of them and explaining them. So let's go to runtime complexities. So it's not logarithmic. It wasn't linear. Is it polynomial? So an algorithm with polynomial time complexity is one whose runtime will be the input size of n raised to some constant power. So it is polynomial. N to the power of 2, n to the power of 3. Yep, 2 for loops. Oh yes, all right. So I got it. Shush. I got it. I think I got it right. Let me just get this out of here. All right. So yeah, I think I got that. It's polynomial time. It's an algorithm whose runtime would be the input of size of n raised to some constant power. So, but my wording wasn't like 100% there again because I'm still trying to learn it, and I'm learning this like with you, whoever's watching this, and like it's literally on the spot. This is like live, how I learn until I get to a point where I'm more comfortable with it, and I start fine tuning the words, and then I start turning them into analogies, which is something that I eventually end up doing, and I actually want to do a video about that as to like the pedagogies that I have created to help wrap analogies around abstract concepts in the context of software engineering and coding to help understand those concepts, to remind you on how to like articulate it. So that's something that I'm going to be talking about one day. But it's comforting to know that I was very close, or as far as like defining what that algorithm was. It's in polynomial time. It's like basically a runtime which the input size of n, as it says here, is raised to some constant power. So being as 2 for loops, it's O of n squared. So thank you, Thinkful. I'm actually gonna hold on to that because I may use that for down the road. Okay, so I'm actually gonna I'm deciding not to go through the rest of this video. If I would have answered this using a hash table, then I would have. So I don't want to blow the solution, kind of expose that yet, because now that I'm thinking that is a possible solution, which I never thought about, that could be part of the optimization part. And what would that look like, right? What would that look like if I did go about this using an object, which I could possibly save for another time, for another video, and or I can just kind of target this now. This is the third Pomodoro, and I can spend more time doing it. But actually, no, I'm gonna wait for another video. I want to separate these. So I have decided to do this solution again and optimize it so that the runtime will be constant time as far as the time complexity is concerned. And I want to use an object because I'm programming in JavaScript. I want to use an object this time to solve this problem where its runtime is a constant O of 1, big O of 1. All right, so I'll save that for the next video. What I want to do now is just quickly recap. We're gonna jump into our next break now and cut this Pomodoro down a bit because I think I've exhausted every ounce of my brain at this point to figure out what. No, wait, actually, no, scratch that. We're gonna use the 9 minutes to talk about the space. I totally forgot about the space complexity. Totally forgot about that. So, why is the space? What did he say? Let's go back to the video. My man's said that the space complexity is constant. What did I say? Oh, I did say best case constant, worst case O of n. See, I don't know if that is aligned with what he may have said because I haven't watched the video yet. But best case scenario is O of 1. So maybe other future videos will help me understand and learn a little bit more about why and why the space complexity is constant. But I had some theories, and maybe it holds true. We'll find out as we unfold these future coding challenges to help me better, get a better understanding. So, actually, I'm gonna retract my last next step, which is to go on break, and it's gonna wrap up now, and just talk about the recap of what we did in this coding challenge with 2 number sum. Okay, so once again, the structure of how I code was outlined using the Pomodoro technique. As I mentioned, they're just increments of time to help you with your time management, right? Very helpful. So that helps me. I don't know if it's going to help you, but maybe it will. Hopefully it does. Try it out. Okay. Next, we identified that in the first video, as far as like the learning pyramid is concerned, teaching others is the way to go, right? At a certain point, you can watch many videos, you can read about it so many times, but if you're not actually doing the thing and getting your hands dirty, you're missing out on 90% of the learning, okay? From a structural standpoint and the approach of solving the coding challenges, I use this strategy called REACTO, which is an acronym for these following words, right? Then we actually dove into those steps where we repeated the question, threw out examples, talked about approach, did pseudocode and actual code. We tested, which Algo Expert did for us. They provided some tests for us, and then we looked at some of the optimization pieces, specifically the time complexities for the solution I came up with. Not necessarily like optimizing it in a way where, okay, we're gonna take my solution and make it better, which is something I want to save for the next video. So with that being said, please subscribe to my channel. I appreciate your time. Thank you for letting me go through this with you. It is controlled chaos, if you will, to a certain extent. And yeah, I hope you guys learned something with this coding challenge. And my name is By Getroman. This is built by Getroman, and I'll see you in the next one. Peace.